수학이 조금 하면서 할게. We need to repeat a little mathematics today because we need to know contents to compute. What is it? Maybe you already know about eigenvalue, eigenvector. Usually they call it eigenvalue and eigenvector. And maybe you can find different name also, but the contents inside the same. I will write eigenvalue, eigenvalue, eigenvector. You already studied about this eigenvalue, eigenvector, right? In mathematics. You already studied this. And why we need this in engineering, we use this eigenvalue and eigenvectors. We use this. And I will give you how to find eigenvalue, eigenvector, and use it by using numerical analysis. Let's see. If you already know, then you can go directly for numerical method. If you don't know what is eigenvalue, then you need to repeat somehow what is eigenvalue and eigenvector, right? If we do calculation fast, then we can do all. If not, then this is you can check from internet later. Now just concentrate. I don't want to give the more talk about this eigenvalue, eigenvector. I want to give you numerical method how to find this. I don't want to give you mathematical method how to find this. To explain numerical method, I need to show you a little bit about mathematical way to find this eigenvalue, eigenvector. Okay, just concentrate. And then if you need, then you can find more information about this. You already know this. We explain this one often, right? Maybe today we'll be talking about this. Today will be last class. Next class we will start about polynomials, and integration, differentiation. We will start from next class. Today we will do eigenvector. Now I write this matrix vector form of this linear equation system. From next class we will, maybe this is the last. Maybe you saw this about these things before. Maybe you saw this. Usually they call it L, lambda, and X. Here X is matrix and a vector, A is matrix, L is a vector, number. We call it this one. Here will be eigenvalue, and this is eigenvector. You know this, right? In mathematics. I will help you to find how to find this. And usually, if you write like this, and here X must not be 0. We have here, this is eigenvalue, this is eigenvalue, this is eigenvector. And you see this is this value is same like as a matrix, like this matrix, right? And let's see how to find this in mathematical way. Okay, I will write directly example. Example 1. 2, 1, 6, minus 1, 0, minus 1, minus 2, minus 1. This is matrix, and I will write this lambda also as a matrix form. It will be like this. I will if you write like this, here this lambda I will apply for unit matrix. Unit matrix, you know that unit matrix is a diagonal. This is unit matrix. Unit matrix is diagonal is 0. Diagonal is 0, and I apply for this, and I write directly. Here it will be lambda I is I apply to this as a unit matrix together. It will be like this. And to write like this matrix, I write here this matrix minus this matrix. I write together, it will be 1 minus L 2 1 6 minus 1 minus L 0 minus 1 minus 2 minus 1 minus lambda. This one I write like this. This is here lambda is number. To apply this, I multiple with unit matrix, and unit matrix is when you apply multiple, it will be like this, and I subtract A matrix minus this matrix, and the result is like this. This is the result of lambda I matrix. To find, now you know this is like one matrix. Now it's like one matrix. To find this, you know this. Here I need to find using determinant, and it will be here. I write determinant this matrix. This matrix is like this. If I write this, from here I can find, I need to find lambda. Okay, I will explain one more time. This is a matrix, and I subtract with this, using this lambda, applying to unit matrix. It will be lambda unit matrix, or diagonal will be lambda, and I subtract, and to find lambda I need to solve this equation, and from here we need to compute determinant must be 0. Okay. Do you know how to calculate determinant, right? you already know, right? This is already, you know. Okay, I will ask you how we can find determinant of this matrix. How we will find? Determinant of this matrix. We need to find this. This inside is this. And now we need to find determinant of this matrix. Please tell me how to find this determinant. Do you know how to find this determinant? Then let me explain you, and then I will. Okay, please concentrate. Here, this line will be plus. This line will be minus. I will write here one more time and we will compute together. This is, I write directly 1 minus lambda 2 1 and 6 minus 1 minus lambda 0 and minus 1 minus 2 minus 1 minus lambda. Let's find this determinant. It will be 1 minus lambda, this one, and this minus 1 multiply minus 1 minus lambda and multiply minus 1 minus lambda plus this one we compute. It will be 0. It will be 0 because of this 0, and this will be minus 2 6 0 6 multiply minus 2 and 1. This is, I compute only plus, and it for minus will be this line 1 multiple minus 1 minus lambda minus 1 minus lambda and minus 1. This is this one I get, and this one will be 0 and this is will be minus 2 6 plus minus 1 multiple minus lambda. And if you write from here, it will be, I can write you final, it will be final is lambda it will be lambda minus 3 lambda plus 4 if you find from here lambda will be lambda 1 is 0, lambda 2 is 3, lambda 3 is minus 1. Now we have a matrix here. We have a matrix here 3 by 3. Therefore, we have a 3 eigenvalues and 3 eigenvectors. Now we find eigenvalue, right? what we will do is we find lambda eigenvalues. Now we need to find eigenvector. Okay. To find eigenvector, lambda 1 is 0. We put here lambda 1 is 0. It will be 1, 2, 1, 6, minus 1, 0, minus 1, minus 2, minus 1. From here, we need to find vector. And lambda, this is lambda 1, lambda 2 is 3, right? And if you put 3 here, it will be minus 2, minus 2, 2, 1, 6, minus 3 will be minus 4, 0, and minus 1, 2, minus 2. For lambda 1, to find this eigenvector, you need to solve this. For lambda 2, to find the next eigenvector, you need to solve this. And when lambda is minus 4, and you put and find for this eigenvalue, you need to find the corresponding eigenvector. This is all you learn from mathematics. This is all you learn, how to find eigenvalue and eigenvectors. This is all mathematics. And now I will now this clean. Can you stop this? Okay. I will give you one more example. If you have a one matrix, and if you have a matrix and if you have a vector, and you need to verify is this matrix is an eigenmatrix or not. Let's see the next example. Example 2. This here is matrix is 0, 1, minus 1, minus 3, 2, 3, 3, minus 2, and 1. We have this matrix, and we need to check this vector. Vector is here minus 1, 1, minus 1, 1. We need to check is this vector is the eigenvector of this matrix. How we check this? To check this, you remember this equation. We need to verify is this vector eigenvector of this matrix. To verify this, we need to multiply this. You know how to multiply, right? This is 0, 1, minus 1, minus 3, 2, 3, minus 2, minus 2, 1, 1, multiple 1, minus 1, 1. You know this matrix and vector multiplication? What is the first, this one? Do you know how to multiply this? goes for first line, this goes for this goes for this, right? And plus. And what will be this? Minus 2? Okay, minus 2. This one? 2. 2? This one? Minus 2? You should minus 2. Okay, I write minus 2. And right? This is minus 2 is right? It will be minus 2, minus 1, 1, minus 2. And if we multiple 2, it will be 2 minus 1, 1, minus 1. It will be like this, right? If we multiple minus 2, it will be like this, right? Then this is same with this, right? This matrix is same like this. Then we can see this. This is eigenvector of this matrix. With this way, using this way, numerical method comes out. The name of this numerical method is Powell method. Powell method. And this Powell method also iterative method. And this also, in mathematical way, you just solve one, finish, right? And iterative method, you need to solve once, complete once, again, until you find you need to solve. This is, we call it iterative method. And here, the same way, this they use this way. They to solve this, we need to have an initial how do you say, the first value, initial value. Like before we did initial estimation x0, right? The same way for this also we find one matrix, initial matrix. And then we start to find this again, compute this. And here, the same way, this x0 will be our initial vector. And here, we solve first y, x. And from here, we find x. And from x, we find here this time also we need to solve this together. This is we solve together. matrix form, and this is the vector form. We solve this together. First we find y, and after finding y we will find this. Here is x is, I would write this for k iteration, it will be k plus 1 iteration, yes, k. We need to solve this together. If I explain like this, you can see that this is I will not write this as a big matrix form. I will not write. And let's see the directly example. Okay. If I write this one in matrix form, you need to. This is maybe to explain detail. I can write this all in matrix form. But let's see the example. This is also 3 by 3. 3 by 3 matrix. Example 3. It will be here 21, 7 minus 1. 5, 7, 7, 4 minus 4, 20. And here we find x 0 matrix, we find 1, 1, 1, 1, 1, 1. And let's see this first iteration. First iteration, I write this one. First iteration, I can write like here will be this matrix 21, 7 minus 1, 5, 7, 7, 4 minus 4, 20. And the matrix is 0 iteration is 1, 1, 1. From here we need to find this 0 iteration. Let's compute this. What will be this matrix? This is 21, 7, 28 minus 26, right? 27. 27, and here is 5, 14, 19, right? And here is 20. Now you see this is I did compute this one. The result is this. To compute this, I need to write x 27, 19, 20. And here x1, this 0, x0, or y0 is this. And to find this one, I will divide 27. It will be 27. And it will be here I choose lambda as a 27. Lambda is 27. And if I divide 27, it will be 27, 1, 19 over 27, and 20 over 27. This is x1. Lambda is this. And for next computation, this is this first iteration. It was next. I take, instead of this, I take this one and compute. Now I take this matrix, this vector x1, for x1 will be, for us will be this one, 1 and 19, 27, 20, 27. And compute again. This is a power method, and mostly here we do until we find these three eigenvalue and eigenvector. This is today we will. I will show you only one method. I did show only one method, and also there is other methods similar like this. You need to, like last time we divided A matrix into two matrices, right? The same way you need to divide this matrix into two matrices, and they call it, for example, I can explain you one method, one more method, but better to understand one. Now I will write for you the homework, and then I will explain you other methods also. Let's see the homework for A matrix is 4 minus 1, 1, minus 1, 3, minus 2. 1, minus 2, 3. And here, to use, to check this method, how method is correct or not, you need to first find the three eigenvalues, eigenvector, mathematical way, and then use this power method, compute, and then you can compare. This method is working or not. This is for this class homework. Okay, I can explain you one more. One more method. divide into 2M2 matrix. And then for this you need to find, like we did last time, it will be who in here you can use to divide to this, you need to for this also you need to make some programming or computation to divide this A into 2 matrix like we did last week. And then you need to compute X here. To compute, I can write, for example, I can do this here, who, here, if you divide who matrix, it will be transpose, this is inverse matrix. Transpose this, divide this, it will be like this. And also, to find from here, first we need to find eigenvalue, eigenvector. First divide into 2 matrix, and then you find eigenvalue and eigenvector. This way. This is if you already know how to find this, then this method will be easy to find. But if you don't know how to divide into 2 matrix, this is then you need to first do this and then do this. Therefore, I didn't show you this matrix because last week also when we divide LU matrix, it takes some time. Right? Better to understand one method. If you are interested, you can use this method, and then using this you can compute this one or find this inverse matrix and do this. Also, this. You can find this one if you are interested in this. I don't want to show this all these examples. It takes long time. I just want to show you only one method. If you are more interested, you can learn this method also. Fourier factorization. Like we did last time, LU factorization. The same way is Fourier factorization. Maybe if you do this, it will be faster. Iteration will be faster. But before doing this, you need to make some more preparation to compute this method. I want to explain until this moment, and until this time. And if you have question, I will take. I can take. Some students, when they do homework, they all did compute by hand. I didn't ask them compute all by hand, just use program, Excel or MATLAB. And some students just compute all 1, 2, 3 and then finish. They didn't continue to the end. Because it's not easy. It's all, you see this, if I compute this again by hand, it takes time, right? Therefore, I just show only one iteration. You need to continue in the home using by program. question, we will finish here. And if you have a question, you can give separate. You need to know. Here I didn't show example. I just skip how to find eigenvector. I just showed lambda 1, 2, 3 shortly. I didn't show how to find eigenvector. To find eigenvector, you need to one vector you need to estimate first. You know this eigenvector, how to find eigenvector, right? You need to estimate. Do you know this? Okay. So I will show you how to find eigenvector also, example. But this will be 2 by 2 matrix. Right? Okay, I will show you two by 2 matrix how to estimate, how to find eigenvector. Okay? I will go first. 2 by 2 matrix. Three, 4, minus 1, 7. From here, determinant of matrix, A matrix. This I write here 3 minus lambda 4 minus 1 7 minus lambda. This is, you know, this 3 minus lambda 7 minus lambda, it will be minus plus 4. If we compute this one, it will be 21 minus 7 lambda, here minus 3 lambda plus lambda cube. This is plus 4. And it will be lambda square minus 10 lambda plus 25 0. Right? It will be like this. And if you you know what is how to compute this, find lambda, right? This is, it will be if you add this, it will be lambda minus 5 square 0. It will be like this. Here now, if you see this lambda will be 1, 2, lambda is 5. From here. This both is 1. Lambda 1 also 5, same. Both is same. Lambda 1 is 5, lambda 2 is 5. From here, if we find from when lambda 1 is 5, it will be 3 minus 5, 4, and minus 7, 7 minus 5. Here minus 2, minus 2. Here plus 2. Right? And here we have x1, x2. It must be this is 0, right? And here minus 2 plus minus 2 x1 plus 4 x2 0, and it will be minus 1 x1 plus 2 x2. Did you see this? This is same. Same, right? Then x1 also 0, x2 also 0. x1 also 0, x2 also 0. From here, what we will do is we will find x1. x1 will be 2 x2. From here, we need to estimate. We find x2 is 1. We estimate x2 is 1. Then x1 will be 2. And here our eigenvector will be 2, 1. From here we need to, if we find from here x1, x2, it will be both are there. But here we need to estimate. We take only 1 because it's same. We take only 1. We estimate x2 as a 1. Then x1 will be 2. This is the eigenvector. For this kind of cases, you need to find. This is the finding eigenvector. This kind of estimation you use in mathematics. You know that maybe next time also we will do this kind of estimation. Some equations you cannot solve using mathematical way. Why it's like this? Because this is all same. This is same. For these cases, we need to estimate this. And also, 3 by 3 matrix. Also, sometimes you have this kind of cases. You need to at least for one. You need to estimate, and then you find, because this x must not be 0. This must not be 0. Okay, now I explained mathematical way how to find eigenvalue, eigenvector, how to verify, and I explained about numerical method of one numerical method how to find this eigenvalue and eigenvector. For today, I finish here. And if you have questions, we can talk.